Hi everyone, I'm going to start right now because I've got a lot to get into this. I've kind of squished some extra stuff in from a workshop that I do as well, so I'm just going to start straight away. My name's James Mallison and I'm going to do a talk on WebSockets and Torrents. But first, a very quick bit of information about me. I work at Trivago. I like posting things that take the mickey out of PHP, but I love PHP. This is why I'm doing this talk. I love PHP. I know you always have to choose the right tool for the job. Because I love PHP, I'm therefore biased, so PHP is always the right tool for the job, but it isn't really. But this is how much I love PHP. Because this is my motorbike in England, and I bought this license plate, J777 PHP. And I said, watch out, JavaScript developers. And then someone warned me not to drop it for the sake of the PHP community, because you know what the JavaScript guys are like, they will rip us to shreds. And there's me having crashed it 3 weeks later. And it hurt, and it was very painful. But I've got another one in Spain now, it's fine. I can't have this license plate in Spain, which sucks, because in England you can, but you can't have a custom plate in Spain, which is rubbish. But I love PHP. So I'm going to talk about WebSockets and Torrents. A match made with PHP and not Node.js, because I don't want to sell my soul. And I want to talk about WebSockets because it's a non-traditional way of doing client-to-server communication. And there's a learning curve with that, so I'm trying to throw as much information at you as possible so you can get past that, at least maybe 3/4 of the way up. And I also want to talk about torrents as well, because I used to do a lot of legal torrenting when I was at university. And so I always think that when you come up with, you want to learn a new language or a new technology, don't just go and do it. You want to have a use case for doing it first. So this is some of the things I'm going to talk about. My use case. So I'm going to talk about my story of why I even bothered with WebSockets in the first place. I'm going to talk about how I implemented the technology for arbitrary data. And this is the most important thing, because if you Google WebSocket tutorial, typically it will be a chat tutorial or it will be a bundle for your favorite framework that just works and you don't understand what it's doing in the background. You can't customize it very easily and things like that. So this is a little bit more raw. And hopefully by the end, you will be able to see how I sent arbitrary JSON from the server to the client, and then you will be able to do the same for whatever you want to do, typically push notifications or something like that. It doesn't matter what the data is. Mine was JSON from torrent data, yours can be whatever. I'm going to talk about an architecture that doesn't require async. I've done async recently in Swift, and it's beautiful and amazing. But in a single-threaded, single-process PHP, in my opinion, it's extremely difficult. So this doesn't require you to do any async, although you should go ahead and learn it if you want to progress after this into something more sophisticated. I'm going to talk about some of the problems that I encountered and how I solved them. Maybe not necessarily the best way, but it's what I did. I'm going to show you a demo. In fact, it's 2 demos, very, very quickly, just showing you WebSockets working, and then another cool thing, and then what I learned at the end of it. So my goal is to show how anyone can send any data over WebSockets using this sort of architecture, and it's not too complex when you get your head around it. So, the story, university, torrents. My university had great torrent speeds, and I have to be careful here because I know this is being recorded and put on YouTube, so I didn't do anything illegal. It was all just Ubuntu. Let's say it was Ubuntu. I was downloading loads of Ubuntu torrents, and I used to take my external hard drive and plug it into the university computers, and then download everything and put them onto the external hard drives. So this was 2012. This is while I was at university, and then I got my student loan. Yes! And what do you do as soon as you get a student loan? Spend it on something stupid. So this little thing down here, it was called the Asus RT56U or something like that. And the reason I bought this was because it said on the internet that this was the best router in the world. Or the fastest. And I didn't know what the difference between a router and a modem was. I just saw that it had pretty flashing blue lights, and I really wanted this, so I went and bought it for no reason. But I realized you could install something on it called DDWRT. It's a kind of a hacked or flashed firmware. And then with that, you could then install the whole LAMP stack on the router. So you could SSH into the router, you could install MySQL, you could install PHP. I did all of this stuff for no reason whatsoever. There was just educational purposes, as the whole of this talk is for educational purposes. But I also could plug my hard drive into the back of the router and download torrents and have the download files transferred straight onto the hard drive. So this was cool for me. And as I was finishing university, I realized, like the use case thing I said at the beginning, I need to get a job. I need to show potential employers that I can do something cool with PHP. So I decided I'm going to do the technology that I know how to work with that I did at university, and also the thing I love doing, which is torrenting. And I tried to figure out a way that I could merge these two things, which is something I believe you should always do, something you're passionate about for the new language first, the passionate thing, your use case first, and then the language after. So I thought maybe I could do a new torrent GUI, a new UI. I mean, this was the transmission UI that I found, that I installed on my home router, and it was, in my opinion, terrible. And when you right-click and inspect element on this, you can see it's just a lot of CSS from this really crappy CSS framework. And I decided, okay, I want to use Bootstrap framework. Nobody say anything about Bootstrap. Back then it was amazing. Okay, shut up. But I like the progress bars, the little progress bars with the animations, and the fact that you could set the style attribute on it to increase the progress bars, and it was really pretty. So I figured, okay, I know how to do the front end easily. How do I get the data, like this UI does, from the server to the client in a structured format, like JSON or XML or something like that? So being a university graduate, the very first thing that I got working was clearly the best. And it was this horrible piece of crap here. And this is the command that I ran, the transmission remote command. And there was a few other things on there, but it gave me all of this rubbish. And what I needed was a combination of the JSON, and I also needed some of these columns here. So I had to use a horrible regex first to get rid of all this stuff. And then I had to use AWK and sed in bash, because this was all going to be a one-liner that could be executed by PHP's exec. And then I had to manually, well, I didn't have to, this is what I did. I manually interpolated brackets and quotes to make my own JSON from this stuff and this stuff mixed together. But this gave me what I needed to provide to the front end. So with that in mind, this is the standard AJAX request that I was doing every 5 seconds or so to get this data and increase the progress bar. So everyone knows how an AJAX request works. You send request from the client to the server, you get a response. That's it. This is what Stack Overflow said when I showed them my code. I was really proud about what I'd done. So I went to Stack Overflow and I said, guys, what do you think? I've done this amazing thing. And they really thought it was crap. And the first thing they said to me wasn't anything to do with my code. It was they said, why don't you hide your downloads? Do something a bit more secure. And I reiterated many times that I wasn't doing anything illegal, but they suggested that I should get another server somewhere, a virtual private server. So I did a bit of Googling, or a lot of Googling, and I found that the Pirate Bay was hosted in Sweden. So what better place, the thought process that I was going through at the time, what better place to get a virtual private server where the Pirate Bay data centers were? Awesome. This was also where they were raided as well by the police, so I didn't think about that. But anyway, I found a virtual private server over there. I needed to pay for it. How do you pay for a virtual private server anonymously for educational purposes? Well, okay, so you've seen the bike crash videos at the beginning, or the picture. So I have a helmet, my leather gear. So I used to work in a place called Preston, a city in England, and I, in Preston, parked my my motorcycle around the corner from the bike garage, and then I walked into the bike garage with my helmet still on and bought this anonymous debit card. So I paid £10 and got this £10 worth anonymous debit card. So the cameras couldn't see me. Went back on my bike, went home. It was all anonymous. I made sure there were no cameras where I parked my bike, again for educational purposes, and I'm going to reiterate this many times throughout the talk. Then I went home, and then I paid for this over Tor. So I connected over Tor and then rented this virtual private server. Theoretically, then I was completely anonymous how I managed to get this. So with this in mind, this is what Stack Overflow basically had told me to do in a way. I still had my own little shitty server, but I made the AJAX request to that, but then my AJAX request would make an SSH call using Torify, I think was the application I used, and at one point I used PHP seclib because it had some nice secure implementation of SSH or something cool. But that enabled the jump from my server over Tor to the virtual private server, which had all the torrents running on. So then that would return the data in JSON to my server, which would then return it to the client. Now this is really, really slow. It took about 10 seconds per AJAX request. But I'd done what Stack Overflow said. This is my first encounter with this community. And I was really proud. Really proud that I'd done exactly what they said. So I went back to Stack Overflow and I said, hey guys, I've done exactly what you said. What do you think? And this was the response that I got. And finally, they gave me something really useful about my code technology architecture. I have to say, these guys really came through for me, because if they hadn't said this to me, I wouldn't be stood here doing this talk now. So they basically said, after all of this, why don't you use WebSockets? That's it. That's all I got from them. So they didn't say why. They didn't say why this is a good technology. It's like going in there and saying you need help with your framework, and then they say don't use a framework. Great. And I have been guilty of that sometimes, actually. But the point is, I went away and I did some research, and everything you see now is a result of that. Here's what I found out about WebSockets. I'm going to give a very brief introduction, because you can Google WebSockets and you can see the handshake and everything else and find out how the protocol works down there. I'm not going to go into that. I'm going to high-level architecture so you can actually go away and implement this afterwards. But a very brief intro is WebSockets hijacks, or kind of piggybacks, the initial HTTP connection, because when they designed the spec, the WebSocket spec, they needed to make sure it worked in enterprise. It worked with all the enterprise's firewalls. So it needs to go in, it needs to sneak in over port 80 or 443, which is what all the firewalls have open, in HTTP. And then from there, it's like a Trojan horse. They're in, and then they allow this big fat pipe to open, which is then your WebSocket connection that you can send information bidirectionally. So you can Google that. But there's two really important things here that we need to talk about, and one of them is the bottom bullet point, and that is because of the PHP, we haven't got to PHP yet, because of the WebSocket connections ping pong mechanism. Then when the server goes down, the client is immediately told the server isn't there anymore. It's just the event is triggered to say it's not there anymore, depending on the library you use, and then you can reconnect every 5 seconds, or fall back to AJAX, or however you want to do it. And it's the same with the server. If a client disconnects, the server is told that the client isn't there anymore. And some code is executed, and you can handle all this in your PHP code, which you'll see in a little bit. So that's one of the things that you need to care about. And the second thing with WebSockets and using this sort of stuff is that when you so we know the ping pong mechanism, right? But it's easy to send data from the client to the server. It's triggered by a user. So you can have a button in HTML. And the user clicks on a button which triggers some JavaScript which says send some data over the WebSocket connection. That's easy. It's triggered by the user. But if you've got this WebSocket server, which is a loop that's happening on the server, how do you trigger something in an already running process to send data from the server to the client? It's not triggered by the user immediately, because you'd have to go through something else to get to that, which we'll come into that later. But it's not just like a single request response dead, which is what you do with PHP normally and HTTP. So with PHP and HTTP, you've got this half duplex connection, which means you send a request, you get a response, dead, and then you do it again, and you process each time. With WebSockets, you have this loop, this event loop, which we'll also come into very soon, which is you have a WebSocket server that's going around and around and around on the server. You're talking with this, and then you can send information out and in at any time, and this is full duplex. So what do we mean by half duplex and full duplex? Well, half duplex HTTP is only one person can talk at once, and then you listen and wait for a response. Full duplex is in a conversation, everyone's able to talk to each other and listen at the same time, like PHP internals. And everyone is able to understand what each other is saying, which is the opposite of PHP internals. So this event loop that I've mentioned, and you saw in the little diagram previously over here on the right, what is that? Okay, so I'm going to show you a really super simple example of an event loop in code in a second. So this diagram here, I want you to kind of stick this in your head and remember it. There's 3 sections, okay? And the architecture that I show at the end could kind of slap on top of this with the 3 distinct sections. So you've got a user making a request to come in over WebSockets. You've got an event loop, which is the intermediary for handling what we're going to do with the data. And then the things that are done separately outside of the event loop is the intensive operations. Only when they are done do we execute a callback to send the data back to the client. So 3 separate areas here. And then, like I said, the diagram I'll show later, you can just throw this on top and you'll see how it's the same. So PHP by default, this is a very simple example, extremely simple of an event loop. PHP by default has this stream select method, which means you can watch multiple streams on it. A stream is typically a file descriptor or a network socket, and when the stream has something on it, then we read from it. So if you look at this code here, very simply, we create a function here that takes a resource, and then we get the data from the resource. There's no error checking, nothing here, it's just very simple. It's just a simple function. And then we have this permanent while loop here. Obviously you'd have other checking and things. I'm leaving all this stuff out. But then this is the goal here, stream select. And what this does is it originally takes an empty array of read streams and write streams, and when somebody reads or writes to this stream, then this unblocks. And this then contains the thing that's been written to. So it's a pass by reference array. Originally nothing in it, and then when someone reads to it, we've missed out the TCP connection stuff here. When someone writes to it, then this unblocks, and then we get to this for each, and we execute this on read as a result of it. So this is blocking, and this is really important. Because the prime directive of event loops is the program is structured in such a way that when there's nothing to do, we don't actually do anything. And we're relying on the operating system to wake it up and tell it, hey, there's something to do now. And this is by a friend of mine called Chris Wright. This means that when I've done all the work that I can do, until there's some activity that I'm interested in, don't do anything until there's something on one of these streams. So if we actually just let this while loop continue around and around and around, and you poll to see is there anything on there, this is different. Because of this call here, then which is interruptible, and we'll get into interrupts in a second, then it's the operating system, the select call underneath, which is a Linux call. You can look at the man page for it, and it says interruptible in there. This is basically what PHP does with this. It yields to the operating system to handle that. So that's the prime directive, and on interruptions, I said that stream select is, or select call is interruptible. We can kind of get into the event-driven programming mindset with PHP's process control extension, because with that we can also handle interrupts. This is kind of signal-based, a little different, but basically the mindset is the same. So I'm going to go through this code line by line, ignore declare ticks at the top for the moment. We create a function, signal handler, doesn't do anything. We could echo in that or do whatever we want and then exit, right? It's just a simple function, nothing special. Then we have this, because you have the process control extension installed in PHP, pcntl_signal, and we're saying here that when we receive a sig term, execute this signal handler. The sig term in Linux is -15. So if you do a kill -15 and then the name of the script, then this is a sig term, a termination. If you do a kill -9, then that's a kill, a sig kill. Here we're not worrying about kills, we're just doing a termination. So it's like if a process is given a -15, it's very much we are allowing the process to clean up, which is what this function can do. So then we echo the process ID out to the terminal, and then we just do a while with a sleep forever, okay? So this is now going to sleep forever. The only thing we've echoed out to the terminal is the process ID, nothing more than that. Move this terminal to the top left of the screen and leave it. Then you open another terminal and you do a kill -15 of that process. Even if we're in the middle of this sleep call here, let's say we're at 5 seconds in, we will seemingly immediately jump to this signal handler, which is really cool because the code here doesn't look like it can do that. It just looks like standard procedural code. You know, it will sleep forever. But the reason it can do this is because of this declare ticks equals 1, which tells PHP under the hood. So you don't see it, but under the hood, PHP is polling for a flag change. PHP is saying, it's not magic, PHP is saying after each low-level executable function call with side effects, it's saying, has this flag changed? Is there an interrupt? Is there an interrupt? So it's still checking under the hood. You just don't see it, so you think it's magic, but it's just fucking, it's not magic, okay? So, but that's what it does. That's what it does. So even if you're in the middle of the sleep call and you do a kill -15, it will jump to here. And that's because if you look at the sleep in Linux, it says the words interruptible. It literally says in the man page it's interruptible. And it's the same with the stream select. It says interruptible, and there's probably others as well, I haven't looked, but any of that interruptible, you can send a signal and kind of jump out and do something else, which is really cool. So I'm showing you this because I want you to get into the mindset of being able to, even if you're in a loop, jump to a function and execute it to then continue around. There's really cool stuff. I used React PHP, which is an event loop implementation written in PHP. And I know there's new ones now, Aries and AMP, which is really getting more popular, but I used React at the time. This is basically my while loop, but a lot more sophisticated and object-oriented, and it has a few methods on it like timers and intervals and things like that. But it's primarily an event loop. We have HTTP and DNS components and Ratchet, which is the WebSocket server and implementation of WebSockets on top of React. These libraries also suggest that you install libevent or libev or libuv if you're on Windows, which you're not because you're a proper developer. Just joking, just joking. But they say you should install libevent or libev because when you call methods on this event loop, just like my while loop there, but a nice object-oriented version of it, when you call methods like add a timer and stuff like this, if you have libevent or libev installed, the interface methods that you call will transparently go to those libraries instead. And these are cross-platform C implementations of the event loop. So it's just the same, but it's in C. And obviously C is a lot more performant than PHP's loops. So why would you not choose one in C? Because it can handle stuff a lot faster. So that's why libraries suggest you should install libev or libuv, so you can use that event loop implementation instead. So I'm going to go into some code now. How do we handle WebSocket events using React and Ratchet? So here, basically, you have to create a class that implements an interface, and then you have onOpen and onSubscribe. These are methods. There's not many methods in this, and you'll see the methods. I'm going to show you. But these are executed when someone opens a connection, a WebSocket connection, or someone wants to subscribe to torrents, for example. I was subscribing to torrents. Once you've created this little class with a few methods in, you then tell the Ratchet code, which you can copy and paste from the documentation, and I have, and you'll see it in a second, that this is our event handler class, and that's it. Then you run it in PHP index.php. You move it to the top left of the screen. That's your WebSocket server and loop running. Nothing more than that. So I've copied and pasted this stuff directly from the documentation. The only thing that's different is the event handler class, which I'm going to create in 3 slides time. The only thing that we have in there again is onOpen, onSubscribe, onClose, things that are executed for us or triggered for us when an event occurs. So when in JavaScript a user says connection.subscribe, then it will trigger onSubscribe in the event handler. Why is the method name subscribe and why is it onSubscribe in PHP? This is entirely because of the WAMP spec. It's just a specification that libraries, if they say they implement it, mean the methods will be the same. It isn't a PHP only specification, even though the interface is a PHP interface that goes with this spec. All it does is implement the correct methods. I'm going to show you the WAMP spec now, the methods that you have to implement in your event handler, and then I'm going to show you the JavaScript which causes it to be executed in PHP. So again, directly from the documentation. Not all of this is from the documentation. I just want to show you that it's nothing magical here. These are the methods that you have to implement. And you don't have to put anything in there if you don't want. Typically, you only need to put something in the onOpen and onClose, and that's it. They're executed for you. If you have no code in there, then it doesn't do anything. And the important thing that I want you to care about is this topic. Typically a string, which you send session.subscribe to torrents, and then the topic is torrents. Even though this is PHP, this is PHP, that's the string. So WAMP is a sub-protocol providing RPC and pub subpatterns, so you don't have to do this in your application layer. This is handled for you. Otherwise, you would have to, as soon as the WebSocket call has come in, figure out if it's a subscription and then store that somewhere and then poll or something. You know, you don't have to care about this too much. So here's our event handler. Little class, nothing special. I have in PHP Storm hidden these methods here, so you can only see onOpen. And what we're doing here is when someone opens a WebSocket connection, so they in JavaScript to literally say connection.open, then it causes this to be triggered. And then in this method, what I'm doing here is I'm storing the connection in an internal array of clients. And also notice I've got this logger add notice, and I'm just logging something out. I want to make this clear that this is just a standard class. There's no magic. It's a standard class that you can dependency inject stuff in the constructor. It's nothing special. The important thing to note, though, is it's stateful. So in a typical PHP HTTP request response, if you had this class here, you'd get a connection in, for example. It would go into this array of clients, and then the connection would die, and then another user would have their own connection, and there would only ever be one client in this array because you know the connection dies afterwards. Whereas because this is being run on a loop in a WebSocket server, this clients array is going to grow and shrink. So you need to be super careful about what you do in this class. Because if you start doing things like database connections, which you don't want to do, and I'll talk about that in a second, then you're going to have to care about closing connections and making sure there's no memory leaks and things like that, which isn't particularly nice. So very simple, just standard on open. And the JavaScript to make this execute, I've moved it to the top of the screen, the PHP. This is the JavaScript. It's very simple. I'm using a library called autobound.js. Connect over WebSockets to this port. And then we do something when the connection is opened. Notice the onOpen here, and we have onOpen in PHP. That's because of the WAMP spec again. It just enables these methods to have the same name. And then finally we open the connection. That is it. This is all the JavaScript you need to make that execute up there. That's how you start a WebSocket connection. Now I'm going to move on to unsubscribe. How do we start asking for torrent data to be pushed to us every 2 seconds or something like that? So again, this is unsubscribe, a little bit more complicated. I've moved up on open and closed it. You can see unsubscribe here. The important thing to note here is we have this loop, which is another thing that we've just passed in the constructor. The actual event loop, React's event loop, is just a set of objects. You can call add timer, start periodic timer. It's just nothing special. It's just a nice wrapper for this while loop. And what we do is every 2 seconds, we make that horrible command line call that I showed you earlier to get the torrent data. And then it keeps doing this over and over and over. And topic broadcast is the important thing here. That topic object that you saw in the spec before, we're just saying send this JSON torrent data to everyone subscribed to torrents. So that's what I came up with originally. We also store the timer and the topic and the connection in that array of clients. Why do we do this? Because when that ping pong mechanism activates, because the browser is closed, then we don't want to keep that timer going and trying to send data out to a client who doesn't exist anymore. They're not connected anymore. So this is where in onClose, you would do an array search in the array of clients and remove that person and also stop the timer. So this is why we store the timer, the topic, and also the connection itself. And the only difference to make that execute this time is this little bit of JavaScript here. Session.subscribe to torrents, the string. And then every time we get data pushed back to us every 2 seconds, we're going to console log it. That's it. We're having data pushed to us every 2 seconds. And it's the user that initiates that. And when they leave the page, we stop the data being sent out every 2 seconds. So that's data being sent over WebSocket. It's very simple. Before I continue, I want to show how this data is being, or this WebSocket server is running on the same server as Apache. Because I was using Apache at the time. You should probably use Nginx. Or everyone says use Nginx now because it's the more modern thing, whatever. I was using Apache. If you do use Apache, what I managed to do is add 2 lines here, not 1, into your virtual host, proxy pass and proxy pass reverse. And we're basically saying that any request that comes in to the server, if it's a standard HTTP request, go and do your whatever Symfony normal PHP stuff. If it's a WebSocket request, go and hit that WebSocket server and do your stuff in the event handler. That's what I had to do to get them working on the same server. Or just use Nginx, it's much easier. So the high-level functionality now at this point is you call .subscribe, which you've seen in the JavaScript that I moved to the bottom, to torrents. Then we store the connection in an array, in the internal array of clients in PHP, and we start the timer against the connection. The timer's hit, we do a broadcast on the topic, send the data over WebSockets. Then finally, we close the connection and stop that timer if anyone disconnects. That's it. So I'm going to show you a demo of where I got to this point, and then we're going to go into some of the problems that I came up with, why this is a terrible idea. Okay, mirror my display. Okay, so I want to show over here, this is the totally legal Ubuntu torrent. There's nothing else going on here. And this is what I'm going to start getting the data for and sending it over WebSockets to this browser on the right-hand side of the screen. So I'm going to start looking at my log. And I'm going to start the WebSocket server. That's the thing I said you would move to the top left of the screen that says loop run. And that's it. And then if I refresh this page over here, and I have to log in, please be the right password. Yes, it is. Notice how every 2 seconds now we're getting this torrent data pushed to us just over and over every 2 seconds. That's just because it's hit on subscribe and it's making that command line call every 2 seconds now. And the important thing to note is that if I look at the network tab here, there's nothing there. I mean, this is Safari, so it's a bit of a shit browser, but you don't see any XHR requests. You just see the data coming in every 2 seconds. And that's over WebSockets. And if I play this now, see how it says downloading down here instead? And then I pause it, and it says paused. So it's doing that command line call that I said, getting the data and pushing it over WebSockets. And in the log, like I said, you can dependency inject the logger. I did that, and then in onSubscribe, I'm just saying the user has subscribed to torrents from the IP address. That's what the connection object you get is. Okay, so you've seen this. What was wrong with this? Well, first and foremost, I noticed that the user was subscribing to the string torrents. I don't know why I cared about this, to be honest, guys, because when I did this, it was just me and my mates. I was playing, me and my mates would be using it and fucking about with it. It wasn't going to be anything particularly enterprise or anything like that, but I wanted to do it like that because I liked over-engineering at that point. And I have since learned over-engineering is not the nice way, but I decided that, okay, if my friend was going to use this and they subscribe to torrents as well, if I have my page open, I'm getting torrents pushed every 2 seconds, and then a friend opens a web page, and then they start being subscribed to torrents. It will trigger that unsubscribe again. So the first person who has nothing to do with this second person is then going to get double the amount of data sent to them every 2 seconds. So this string torrents isn't on a per user or per connection basis. So what I came up with is a bit of a hack, and that is that the topic has to be a string according to the specification. And I did look at the WebSocket specification and the WAMP spec to make sure that I wasn't doing anything wrong, and it doesn't say anything about that. It just says the topic has to be a string. So I made my topic JSON, and within that I put the user ID, just the user ID from PHP. And then when user 245 subscribes to torrents and user 246 subscribes to torrents, the topic is therefore different, so they will have data sent to them and broadcasted to them separately from each other. So that's the first thing I came up with. Obviously, you could probably store the torrent data in the actual event loop and then query that instead separately. What I envisaged was a MySQL database with the user ID and also the torrent hash, and then I would just get the torrents and then filter for the user ID and do it that way. So this worked, but the same user could get duplicate data still, because 245 and 246, fine, but 245 on one page and 245 on another still means that they're going to get the same person's going to get the data doubled. So this brought me to authentication and duplicate data. So I was passing the user ID from PHP to JavaScript, and I realized that, I don't know why I was considering this, but again, a bit of over-engineering, but if I wanted, or my friend wanted, he could pause JavaScript execution, change the user ID to 246 or 247, and then get their torrent data passed to them instead by resuming JavaScript execution. So it wasn't secure or anything, and I ended up coming up with basically what PHP does with session authentication, which is create a unique token every time there was a connection, store this in the database, and then every time you refresh the page, you get a unique token, a different one. Every time you refresh, new token. So what does this allow us to do? Well, I put it in the string here that I was sending. At that time when I did this, I didn't have random bytes. I only had OpenSSL random pseudo bytes, which wasn't fork safe, but we have this now. Send this random token, this the unique token, and when we try and connect, or when we try and subscribe to data, to torrent data, it checks the database. And then if they are the same, it changes the token, so the same token can't be used again. That's basically what I came up with at the time. The most important problem that I came across, though, was it was blocking. So with that implementation that I showed you, making that command line call, which took 5 seconds or something, during that 5 seconds, no one else can request to subscribe. No one else can open or close a connection and have it trigger something in the code because it's blocked. This is a single-threaded process. It's a single process. So this, imagine it's just a while loop that's going around, and you put a sleep in there directly in the code, or you put this database query, or you put what I did, which is the exec to get a call to get the torrent data. It's gonna, and it takes 5 seconds. Nothing else happens during that time. So it's blocking. And the way that I got around that was, first and foremost, I figured out you could use another process to do the work. It's a bit of a hack because you're still polling the process for when it's echoed out the data, but it worked. Or you could use a job queue. And I'm going to show you both of these solutions that I came up with and discuss quickly the downsides of using these two solutions. So you don't have to use the React child process library if you were doing this. You could write this yourself. But basically, it starts another process with the data, whatever getting the torrent data, So then the event loop can keep going around, but it polls the output of that every 5 seconds in userland. You're still polling in userland. And then when we get data, we then broadcast that. That's it. Nothing special. This is good. It works. It's great for a little prototype, or if not many people are going to be using it. But it's not scalable because the processes are on the same machine, and the process on an operating system is the biggest unit of execution you can do. So you've got all the overhead with it, like file descriptors, file handlers, memory allocation, and all this stuff. So you don't want to do processes in production, definitely not. But for a little example of it working, sure. So the option number 2 is use a queue. So this bit at the top, again, copied and pasted directly from the documentation. You don't need to care too much about this. It says that anything that arrives over port 5555 hits this method in our event handler that doesn't exist yet. I haven't created it yet. I'm going to create it. So send any information from anywhere, another process over port 5555, and it will execute this function here. And in onSubscribe, instead of doing the command line call every 2 seconds, I'm using Fiendstalk here. I don't do that anymore. But you just send the data that needs to be done, so get me torrents, put it in the queue, and then continue. So there is overhead putting something in the queue. I haven't figured a way of getting around that yet. Maybe do that in a separate process or something like that. But you just fire and forget. So that omzmq response method here, which I am now creating, that's literally it. It's just a function in this event handle class that you've seen before. And all I'm doing is you get this data that's been sent over port 5555, and then you broadcast that. Actually, in the implementation I have here running, it just loops through all the clients and sends it out for ease of use. So the architecture now kind of looks like this. Subscribe like before from JavaScript, but then we fire and forget into the queue, and then it keeps on going around. Then a queue can have any number of these workers reading from the queue and then doing it in whatever language you want to, as long as it has a 0 queue binding. And then when it's done, it finally sends it over port 5555, which is a one-liner, by the way. And then finally, we send that to the client, which means all these workers can be in whatever language you want. And if you remember that 3 thing I told you about at the beginning, that diagram that I said there's 3 separate parts, this fits literally onto that. You have the 3 distinct parts: the request coming in, the intermediary for asking for data, and the process is executed outside of the event loop. So I'm going to show you now a second super quick demo of the exact same stuff happening, but this time we're going to do some inter-process communication and send something in from somewhere else. So this stuff's still being sent. I didn't stop the server. Notice down here we're still sending the torrent data, but here in our WebSocket server, I'm going to create for port 5555 an on-terminal test method. And in the actual event handler, here's the on-terminal test. Like I said, I'm just looping around all the clients. I have this little thing here where I just store the original topic. You don't need to care about that. And then I broadcast it. Nothing special. And finally, this is the only lines, the only lines you need to use to send to this data. So, hello phpday. And then we send this information over port 5555. That's it. That's the one line that your worker would do to get stuff back into the event loop without blocking it. So let's execute that here. Let's send it a few times so we can definitely see it in the terminal. There we go. Hello phpday. So I've just put that in and used the event loop as an intermediary. The event loop isn't doing the actual processing itself. It's a separate process. This is a separate process that did that. That was the wrong one. Okay, so you've seen a separate process. That's what I came up with at that time. What about scaling? Well, you could use HAProxy or whatever. You could do any of that sort of stuff. I've never used HAProxy. So you can do it in software and have real control of it. So this is what I came up with for scaling. Again, me and my friends were going to be downloading a load of legal torrents. There was no reason to do this, but this was what I found interesting. You could have an API with database or Redis that literally has key value pairs of your event loops. These event loops are very performant, but if you wanted more and you wanted to scale, I'm guessing this is very similar to what Pusher does, all these services you can use elsewhere. But basically, you would have a list. You can round robin them, or you can ask each one individually with that onZeroMQ function call, which one has the least number of clients connected. Call the chosen WebSocket server, and then fire that information into the queue like before. Obviously, the message that goes into the queue needs to know which event loop it got requested from. And then you send it back over ZeroMQ or whatever messaging technology you want to use. So the workers are scalable. You can Google that. You can easily scale workers separately. The event loops themselves are scalable as well, because you can tell operations to add a new event loop, add that to the database or Redis, so the next client connecting becomes a part of the decision-making process. So the next client connects, and then they say, okay, give me the WebSocket server with the least number of connections and the event loop with the least number of clients, and then choose that one, and then go through your stuff again. And you can auto-scale it and use AWS amazing stuff. So this is a software way of doing it. So that was WAMP version 1 that I used before, and I still recommend you should use that because WAMP 2 gets really complicated. I didn't need to use ZeroMQ. I actually just used RabbitMQ, and the worker can push the data straight back to the client. So if you wanted to do this, you wouldn't need to use ZeroMQ. I love RabbitMQ. I think it's awesome. You can just do that instead. I used Vorix Throughway, which is a library that's built on top of Ratchet. So I don't want to say there's millions of libraries that you should use. There's literally React, Ratchet, and then Vorix Throughway on the PHP side. And on the JavaScript side, there's autobahn.js. That's it. The WAMP specification libraries. Nothing special. So I actually do a workshop on this because I think it's very complicated, in my opinion. I don't think it's a dev-friendly library. I think it's over-engineered, and I think the messages for errors are particularly bad. But it's very, very powerful. It means there can be JavaScript clients or PHP clients. So you know the clients that I said, typically JavaScript connecting to the WebSocket server, it could be a PHP one that's sending stuff into this as well. So imagine the JavaScript client now says session.register. This is the new WAMP spec method. They say that I am available on test.rpc. That is my endpoint. And then the router now says, okay, I have a client on test.rpc. And then the PHP process can say session call. And even though this is over WebSockets, and this is over just a TCP connection, nothing magic, nothing special, then this allows the hi to be sent from one process, one client, to another. The important thing here is this information at the bottom that I copied and pasted from the documentation again. Avoids the traditional distinction between client and server backends. You don't need to care too much about this. So you can have one JavaScript client, like before, but then another JavaScript client that says call, and it sends the data hi to this one. This is literally another browser. This is basically like peer-to-peer communication. And this is the next step which WAMP version 2, which is very powerful, allows. So where we had the pub, sub, and RPC stuff from WAMP version 1, now we have register and call, and we have publish and subscribe. So you can send torrent data over this way. You can send any data this way. And this is language agnostic. We have session register or session.register in JavaScript. It doesn't matter. So what did I learn from this? I learned that using an event loop doesn't mean you're automatically not blocking. You do anything in that, and you are blocking the event loop. So you need to do stuff separately outside of the event loop. I will never touch pthreads ever in this context. You could try it, but I will never do it. I find a queue and a separate process so much easier, but you probably could use pthreads. It's just the Joe Watkins, the guy who runs pthreads, is very honest, and if you ask him, should I use pthreads, he usually says, no, you should not use pthreads. It's the worst thing ever, even though he maintains it. I also realized I could have done this with Node.js, but I'm not really sad. And I realized that at the very end of it, I could have just made RPC calls to the server, to the torrent client, to get the data instead of that horrible command line call, which I only realized at the very end, as is naturally the case when you're a graduate and you think you've just done the greatest thing in the world. And I realized as well that you didn't have to broadcast on a topic. Each connection had a way of sending data as well with WAMP version 1. So the event loops that I used, the event loop was React. You can also use AMP-PHP. This is really modern, really upcoming and popular. libevent or libev are those cross-platform C implementations of the event loop that I highly recommend you install because it's just in C, so it's obviously 10 times better. I use Ratchet and Throughway, Autobahn.js. If you want to use WAMP version 1, which is what the majority of this stuff was, you need to use an older version of Autobahn.js because they're really pushing now version 2, which I think is overly complicated. Really cool, but overly complicated. I think it's 0.8.2. It's on GitHub. You can go on tags and then find that version. And also, definitely look at the difference between the two and go through the same process if you're interested in this sort of thing. And that's it. Thanks for listening.